This is Alaska, home to some of the deadliest predators on Earth. But seldom do we see or even think about these hunters on a deeper level. Some of the fiercest animals here live under the waves. Alaska's deep blue is an extreme environment. Cold, dark, competitive. The only way to survive here is to kill. As the sun goes down, a deep water monster stirs. Humboldt squid are usually solitary, but not when they all have the same idea. Tonight, this army rises to hunt the shallows in utter darkness. His billiard ball-sized eyes are tuned for optimal night vision. Each Humboldt can grow as long as a person and weigh up to 100 pounds. Surprisingly intelligent, they communicate in the dark by flashing messages with their skin. Ten limbs lined with flesh-tearing teeth and suction cups drag victims into a beak-like mouth. And when there isn't enough to go around, they make a meal out of each other. They're cannibals. A defensive squirt of ink is too little, too late. Daybreak calms their frenzy, and they retreat back into the deep. The rising sun awakens a world of battling creatures. In the shallow waters, Alaska plays host to an ever-escalating arms race. Here lives a voracious saltwater predator, the starfish. There are some 2,000 species, most with 5 arms. But the sunflower sea star is armed to the max with up to 24. This hunter feels and smells its way with 15,000 tube feet, moving at a speed of almost 3 feet per minute. In the slow motion world of the seafloor, it's a speed demon, at least to its prey. Like this cockle. He has his own clever method of transport, a powerful foot. But one leap in the wrong direction spells doom. But even the ravenous sea star has its own enemy. This tank-like beast is a rare Puget Sound king crab. Its specialized claw impales one of the sea star's 19 arms. But the star has a trick up its sleeve. It will jettison its own appendage. The king crab gets dinner, and the sea star escapes with its life and plenty of limbs to spare. Here in Alaska, it pays to be a hunter who can hide in plain sight. And no one does it better than this camouflage queen. She is the giant Pacific octopus. She has a calculating intelligence, and she should. Her 9 brains fire nearly 500 million neurons, almost twice that of your average domestic dog. One brain is in her head, and one in each of her 8 arms that control movement. She's powered by 3 hearts that pump copper-rich blue blood. Today, eating is her priority. She's already bigger than a human, but she's bulking up for her big moment. With her knack for invisibility, she's setting the stage for a crustacean apocalypse. This crab is in for the surprise of his life. That's not a rock. The octopus paralyzes her prey with venom delivered by a hidden beak. There's no escape from this sucker-filled fate. 280 suction cups per arm can taste as well as grab. Though they only live about 4 years, giant Pacific octopuses can reach 20 feet long and weigh up to 200 pounds. A body like that requires a lot of crabs. Even when she's full, she hunts for more, stashing live crabs for later. Fueled up, she's ready to perform her final disappearing act. She's carrying over 50,000 fertilized eggs and needs to find a hideaway she can defend. This cave is perfect. Here, she braids together her thousands of rice-sized eggs and glues them to the walls. For 6 months, she constantly pumps water over her eggs and washes away parasites. She can't leave them, even to eat. Her color fades. She loses half her body weight. And this once fierce queen is left weak and at a disadvantage to protect her fresh eggs. Irresistible to the sunflower sea star. And this time, he's brought along a buddy. He is here to redeem himself from his limb-only lunch. She must find the strength to defend her babies. First, she forces water over the eggs to help free them from their shells. Then, she makes the ultimate sacrifice. Her carcass becomes bait, drawing the bandits away from her young. And they need all the help they can get. Of the tens of thousands that hatch, on average, only 2 will survive. Dwarfed by the vast ocean they've been born into. Alaska's coastline is the longest in the United States, nearly 50,000 miles. When we think of Alaska, we think of endless forests. But some of its most abundant forests are underwater. The kelp forests are less known than the California kind, but just as rich. It is home to the colorful sea urchin, whose 5-inch-long spines help ward off most predators. Except for this guy, the wolf eel, which is neither wolf nor eel. He's a 7-foot fish with a predatory punch. He's as frightful as he looks. His ferocious teeth are worn from years of crushing the life of very tough prey. With one of the strongest bite forces in nature, he can pulverize hard-shelled animals in seconds. Despite his trap jaws and frightful mug, he's got a romantic side. And this is the object of his affection, a lady in red. She rather likes his rough looks. Soon they're moving in together. Wolf eels mate for life and will occupy the same rocky den year after year. But the honeymoon doesn't last long. Soon, the wolf eel cave is filled with kids, or potential kids. 10,000 of them. It's crowded. And both parents spend most of their time protecting their clutch from predators. Finally, the day comes for the hatchlings to wander into the great blue. Few will survive. But those who do will eventually search for a good rock and a willing partner of their own. With luck, they'll be just like their parents, devoted homebodies for the rest of their lives. For migrating animals, home is but a memory. Alaskan salmon spend most of their lives away from home. They wander more than 1,000 miles of open ocean. But at the end of their lives, they set their sights on returning to their birthplace to spawn. The Earth's magnetic field directs them. They use it like a map. They know the route based on what magnetic field they are in. And when they get close, their keen sense of smell pinpoints the exact river where they were born. But first, they must run the gauntlet of Alaska's top predators. And perhaps the most feared is the aptly named salmon shark. This is the moment they too have journeyed thousands of miles for. The salmon cling to the walls of fjords, trying to outflank the sharks. But instead of offering safe passage, the rocks may doom them. Unlike their cousins, the great white sharks, salmon sharks hunt in packs. Together, they push the salmon against the fjord wall, then drive them towards the surface, cutting off escape routes. The shark misses on the first strike, but endurance is its specialty. Tight circles around the fleeing salmon should tire the prey out. At least, that's the plan. Another miss. He dispenses with the gymnastics and goes for hot pursuit. Salmon shark have excellent eyesight. Eyes are positioned far forward, enabling sharp binocular vision to locate their prey. An enormous advantage for closing in on small, fast salmon. Traveling at speeds up to 50 miles per hour, they're one of the biggest and fastest fish on the planet. Once the feeding begins, the sharks are relentless, gorging themselves in the salmon-packed waters. Like wolves, a group of sharks all strike at once, devouring everything in their path, storing energy for reproduction, migration, and leaner days. The salmon who slipped by unharmed continue on to the intertidal zone, where the ocean and rivers merge towards the freshwater streams. But before the salmon can swim upstream, they must adapt to the freshwater mix. After traveling hundreds of miles, they're so close to fulfilling their purpose. They have just one more obstacle to overcome: an alley of daunting predators. Brown bears have timed their arrival perfectly. They must pack on the pounds to prepare for hibernation. And these cubs are getting much-needed fishing lessons. Mom makes it look easy. This is the first time the cubs have come across food that tries to get away. It's the fish that make these some of the biggest bears in the world. Salmon are high in calories, and here in the shallows, pretty easy to catch. But this is just target practice. The main course is further inland. Bears have an incredible sense of smell. many times better than a dog's and hundreds of times better than ours. A hungry grizzly smells an unexpected opportunity. Millions of calories have washed ashore. A beached humpback whale. Grizzlies are usually solitary, but the smell draws them together from miles away. They're not used to sharing. Latecomers are especially unwelcome. He settles for the short end of the whale. A safe distance from the others. There's not much to eat on the tail, but all he has to do is wait. Soon the other bears eat their fill, and then some. It's like after a Thanksgiving feast. With everyone else in a food coma, the hungry male helps himself to stress-free seconds. Bears not sidetracked by the unexpected windfall follow the salmon further inland to the spawning grounds. The narrowing rivers concentrate the salmon into these waters of their birth. Here, the next generation is created in a mass spawning. The parent's job is done for good. Each female lays about 1,500 eggs, but few survive to become adults. Just as the bears stalk the salmon, others hunt their offspring. A massive swarm prepares to invade these Alaskan waters. Grouping together in the thousands, moon jellies arrive. A giant lion's mane jellyfish joins them. They're here at the perfect time, when the temperature and currents are just right for the explosion of salmon eggs. They're an unstoppable flotilla of hungry, gelatinous predators. Stinging tentacles force toxins into their prey, rendering it helpless. The tentacles trap the eggs and move it toward their mouths at the center of their bell. The eggs that survive the onslaught grow into miniature versions of their parents. And spill out into the deep blue, where some of Alaska's largest ocean creatures hunt. Right on schedule. Humpback and orca whales arrive to these summer feeding grounds. For the orca, everything is on the menu. Today's craving, humpback whale. It's the baby they're after. The orcas are masters of the ambush. First, they circle the humpback pod. Then, they separate the mother from the calf. Finally, they capture the calf and hold it under to drown it. The predators are hungry, so they go for the easy pickings. The calf's tender tongue and lips. The cunning orcas dismantle the carcass, storing it on the bottom for later. Alaska's extreme conditions inspire innovation in its hunters. Competition is stiff, but cooperation often reaps great rewards. The humpbacks can play that game too. In fact, they're renowned collaborators. They use sophisticated communication skills to hunt as a group. Each member within the hunting party is given specific roles to perform in the group hunting ritual called bubble net feeding. Today's lunch, herring. A lead whale dives under the fish. She is the fish scout and bubble blower. When she locates the fish, she blows a curtain of air, spiraling upwards and around the school. The frightened fish huddle together. Then the pod leader signals the others to lunge to the surface in unison, jaws agape, scooping up their prey. With a little teamwork, each whale can consume thousands of fish in a single gulp. An inventive strategy for making the most of this brief bounty. The sea ice that once engulfed the coastline is melting. Male walruses rest on floating bachelor pads. But their platforms are shrinking, and close quarters cause tempers to flare. They abandon their melting ice floes in search of food and dry land. Now, one of Alaska's largest marine mammals is in a race against time. With nothing solid to rest on, a walrus can drown in Alaska's icy waters. Not far from the males, females and their young also contend with their melting havens. In Alaska, even the biggest babies start out inexperienced and defenseless. Born less than a day ago, this pup gets a much-needed swimming lesson. This is serious business. Mom and baby begin their pursuit of land, and the little one must keep up. After miles of swimming, they finally make it to a resting stop. But there's a problem. A beach packed with irritable males. The mothers are too exhausted to come ashore. They fall asleep in the water, clutching babies to them. After recharging, the mothers and their young finally haul out of the sea. But it's not much safer here. Huddled together, 20,000 walrus bodies stretch far up the slopes. They've reached a critical mass. And blood runs freely from slashed noses. Creatures weighing up to 2 tons clamber over a heaving sea of flesh and tusks. These are dangerous times for walrus babies. Some struggle onto their mother's back to get above the fray. Fierce mothers fight off threats to their babies. But the shoreline quakes and bodies writhe, tightening the space around them. This baby is no match for the 2-ton males that intensify the squeeze. Even the water provides no safety. The Arctic summer is short, and ice begins to freeze again, freeing them from the deadly beach. Moms and vulnerable calves can now escape. They pour into the sea. Calves will remain with mom for the next 2 years, learning vital life lessons they'll need to survive in this harsh landscape.
Two apex predators dominate the ocean. The great white shark, a lone hunter, and the orca, known as the killer whale. Both sit atop the oceanic food chain. So when orca begin to hunt great white sharks in South Africa, it's big news. Experts want to know, will it happen again? And if so, where? It's happened before. Orca have hunted and killed great white sharks. one of the first reported cases off the coast of California in 1997. And again in 2017 off South Africa. 5 dead white sharks washed ashore. Shark scientists wondered why orca would hunt dangerous prey like a white shark. With attacks happening in oceans around the world, experts are looking for similarities and patterns and what the effect would be on the marine ecosystem. Particularly in New Zealand.
When the orca started to kill the great white sharks in South Africa, the rest of the sharks actually disappeared and haven't come back for years. If that happened in New Zealand, not only would we lose this population of great whites that we've learned so much about, but it would also be disastrous for this ecosystem to lose an apex predator like that.
There are several theories about exactly why the sharks vanished. But the coincidence of the orca attacks and the disappearance of the sharks is hard to ignore. And there's a lot at stake, including the health of the marine ecosystem. New Zealand has a local orca population of between 150 and 200, while the white shark aggregation is one of the largest in the world, estimated to be over 5,000. If the orca begin to go after white sharks here, they have plenty to choose from. New Zealanders Kinna Scalay and Dr. Ingrid Visser are investigating. Orca could be hunting great white sharks already, but no white sharks have washed up on New Zealand beaches. So they're searching for other signs of orca predation. Any strange behavior, wounds from an encounter, anything that points to orca hunting white sharks.
I'm coming down the port side.
Roger. Really is interesting, Ingrid. What do you think?
Local great whites are in New Zealand waters from December to June, when many will leave on their annual 2,000-mile migration to the coast of Australia and the tropical Pacific. Local orca, on the other hand, remain in New Zealand waters all year round, roaming the coastline in search of prey. Ingrid is New Zealand's top orca specialist, but today is her first dive with great white sharks.
I'm pretty stoked to get you in a cage with my favourite population of great white sharks of the world.
I have to admit I'm pretty buzzed about it myself, that's for sure. Well,
What do you think?
it's pretty amazing for them to see New Zealand sharks this close. I really expected to be quite scared, but in the safety of the cage here, it's quite impressive to just watch them doing their great white sharks, that's right. Well, back up on us.
It's their specialty.
Great white sharks in this area are curious and aggressive, which makes them dangerous. Orca and white sharks have shared the top of the ocean food chain for millions of years. So why would orca attack great whites like these now?
Even though orca are the largest of the dolphin family and they can be friendly, we still have to consider that they are one of the top predators of the ocean.
Ingrid's research tracks the 200 or so orca living in New Zealand's waters.
Yeah, I know, big guy. Hang in there.
The exciting thing about this adventure for me is that we've got 2 top predators and we don't really know what's happening between them.
Orca and white sharks are the top 2 ocean predators, yet they're fundamentally different. Orca are air-breathing mammals. White sharks are water-breathing fish. Orcas live in pods of up to 40, made up of individual family units that remain together for life and hunt cooperatively. Some new research suggests white sharks may occasionally hunt in groups, but they tend to hunt alone. The largest great white ever recorded measured over 20 feet and weighed 5,000 pounds. Small for an orca. Killer whales can grow to 30 feet or more and weigh as much as 20,000 pounds. But as different as they are, orca and great whites are both sophisticated, tough, and hungry predators. Kinna and Ingrid dive again and again, searching for evidence.
Well, that was a pretty amazing interaction, Ingrid. Those two sharks actually physically bumped into each other. Nobody wanted to back down, and they were leading a pectoral fin onto pectoral fin. That's quite a sight.
I think this was more of a, get out of my territory interaction. I don't doubt that if the orca were going to take on one of these great white sharks, they'd be thinking very carefully about it before they did it. It wouldn't be a mistake, and it wouldn't be something that they would take on lightly. And there seems to be a very strong hierarchy going on here. When we see that with orca, it's usually a nice social interaction. Really is an impressive predator-on-predator interaction, that's for sure.
In 2017, a predator-on-predator interaction of another kind took place along the coast of South Africa. 5 dead great white sharks washed up on local beaches. The news is shocking. Scientists conducted an investigation. Of all the evidence collected, it was the bite marks on the shark bodies that revealed the killers. The teeth marks belonged to orca. Stranger still, the killer whales had taken only the shark livers and left the rest of the bodies untouched. This was the first recorded case of orcas killing white sharks in South Africa. Shark and orca scientists wondered when and where it might happen again.
We can't rule out that the orca here in New Zealand could hunt great white sharks in exactly the same way.
The Foveaux Strait sits at the southern end of New Zealand, over 6,000 miles to the east of South Africa. Both regions have large populations of great whites and roaming pods of orca, a combination that resulted in a fatal confrontation in South Africa. And if white sharks and orca ever cross paths in New Zealand, this is where it could happen, in the Foveaux Strait.
We've got a couple of good players here. There's two sharks that are pretty boisterous. Pretty cool.
Large, boisterous, and aggressive great white sharks. What possible motive could an orca have for attacking a great white? There isn't a clear answer, but to Ingrid, it makes some sense.
Typically in New Zealand, the orca are not just targeting prey to take the whole thing. They're focused on particular parts of them, and that's the liver.
When the South African orcas killed the great whites, this is what they did. Hunting for liver with great precision. Liver is a prize for any predator. To hunt, mate, and migrate thousands of miles takes energy. Liver is pure fuel. So when they hunt, they're filling the tank. New Zealand orca feed on the 25 species of rays and skates that swim in local waters. The preference for rays is unique to orca in New Zealand. But recently, local orca have acquired a taste for shark liver from a smaller cousin of the great white, the seven-gill. And evidence suggests South African orca started on seven-gill sharks and graduated to great whites. Ingrid Visser and Kenneth Scalay are looking for evidence that orca are hunting great white sharks in New Zealand waters. Ingrid has evidence that there's a disturbing pattern in orca hunting. New Zealand orca are hunting seven-gill sharks, just like the South African orca. Seven-gill sharks grow to 9 feet long and 200 pounds. A much larger meal for an orca than a small ray. But the seven-gill shark is no easy prey.
Seven gills are relatively new on the orca menu, but I've seen it a few times now. You see the orca and they're very, very precise in how they do it. I've got footage of orca with the seven gills where they've ripped the pectoral fin right under the pectoral girdle there, and they've extracted the liver. One of the things I find fascinating is how the seven gills will actually turn and defend themselves against the orca. The way the orca hunt the seven gills is pretty impressive. First of all, they'll come in and they'll karate chop the sharks, so they'll just come in and lift their tail up and whack them on the back. Then they grab the sharks by the pectoral fin and rip them open and pull the livers out.
Ingrid captured rare footage of orcas hunting seven gills in northern New Zealand. Their precision in hunting for shark liver is clear.
What's really fascinating is that in South Africa, the orca started by hunting seven gills, and then they moved on to the great white sharks. So, knowing what's gone on in South Africa, what concerns me is exactly the same thing could happen here.
A concentration of seven-gill sharks lives up along the western coast of New Zealand. Kenna has dived with them for years, knows just where they live and how they behave.
Beautiful.
They decide to drop in and see if the seven gills can give them any clues. Fiordland National Park is a vast, remote wilderness on the western shore of New Zealand's South Island. Most areas are accessible only by helicopter or boat.
You know, really, you fly over these mountains and you're in a completely different world and then under the water, it's completely different again. Different to just about anywhere else you'll dive. Amazing.
These deep fjords are murky, stained with tannins from the ancient forest. It makes the water dark, even in the middle of the day. If orcas came here to hunt seven gills, it's possible no one would ever know.
I actually haven't been in here for about 2 years. Wow. So that's after diving here month in, month out for many years, and I really felt like I knew these seven gills so well. All this talk about orca eating them, I just kind of want to come and have a look.
Yeah, absolutely, Kinder. And I mean, look, that ties in with the sightings that we've had recently of the orca coming down this bit of coastline. So I'd be fascinated to know if they're coming up here to your seven gills.
The only place for Kinna and Ingrid to land is on a small fishing trawler in the middle of nowhere.
My little secret spot is only just literally 1 minute's flying time from here.
Right.
So I think it's easiest if I gear up here,
Yeah.
and then I'm going to hop in the helicopter and just buzz around there and bomb in.
Diving without a cage, Kinna will have to be careful of the seven gills and keep an eye out for orca. They could be anywhere. Kinneskalay is paying a visit to an aggregation of seven-gill sharks in Fiordland National Park, New Zealand. And knows just where to find them. He's looking for any signs that orca are hunting these seven-gill sharks.
The murky water really works well for these guys. You just can't see them coming. As they approach you, you just see them wide under there. Now, it looks like an evil kind of ghost groom. Shark materializes out of the mist.
The seven gills are here, drifting in and out of sight. Checking out the intruder.
Scientists have found remains of really big animals inside them. 3 items is bigger than a human. And really, the only way that they can do this is if they're pig hunting. When you see one coming out of the dirt, you almost know there'll be another one coming from one side. And if you look the other way, there'll be another one sneaking in there too. Oh, and they're relentless. It's good to see that these seagulls are here and up to their usual traits. But, to be honest, to find on this dive.
Seven gills may be prey for orca, but these sharks are no pushovers.
Oh, this one is business. But it's the ones that sneak up behind that I really have to worry about. guy. Yeah, these guys are revving up above our tribune. Oh, I think it's time to get out before they take control of the situation.
That was awesome to go and visit those guys.
Yeah, great jump.
Yeah, cheers, mate. That splash and the noise of the helicopter really has to attract them. And they were straight on top of me when I got in, but not as many as I would have expected to see.
Really? Okay, well that's really interesting because given that we know historically that orca are coming in here, then we've had the reports recently and now you're seeing less sharks in here too. So, you know, it's indicative that something's been going on, right?
Lower seven-gill numbers could mean a few things are going on, including predation by larger predators, like orcas. That would mark a change in their usual diet. Traditionally, New Zealand orca hunt the many species of rays and skates that live in these waters. Like all dolphins, they have a special ability to find them.
Orca hunt using echolocation, which is a series of clicks that they send out that bounce back and give them incredible information. They can tell even if a shark has a full tummy.
It works like sonar. The orca can detect their prey even when it's buried in the sand. But filling up on rays and skates can be hard work and burn a lot of precious energy.
You see them? Look, they're in a really tight group over here, mate.
Many rays are bottom feeders and spend much of their time on or buried in the sandy ocean floor. Orca jaws are not designed to grab them off the bottom. So the orca work together, chasing the rays upward and catching them in the open. But ray hunts don't always go smoothly. Rays often flee to shallower water. Making it dangerous for the orca. There is the risk of a fatal stranding as the tide goes out. And the ray may still escape. When orca hunt rays in New Zealand, their size is not always an advantage. After a lot of work and coordinated effort among several orca, they catch the ray. But it's a tiny payoff for all that effort. And compared with white sharks, rays are a snack. One 700-pound great white shark liver could be equivalent to nearly 175 ray livers. And it's a lot more work to hunt multiple rays. While it is more dangerous to hunt a single great white, it might be worth the risk.
It's really hard not to think when you see animals that big that their liver must be gold to a liver-eating orca.
A great white liver can grow to 25% of the shark's total weight. If a 12-foot great white weighs 1,000 pounds, it may have a liver weighing 250 pounds. A big payoff for the orca. Kinna and Ingrid are off one of the Fovo Straits' large colonies of seals. Over the summer, the white sharks consume many. Their livers are swollen with seal blubber and oil. Ingrid and Kinna are looking at the length of the sharks to estimate their liver weight.
There's one coming up on the starboard side there. It's coming right in there. How big do you think that one is, Kenneth?
That male there is quite a bit smaller, and he's well logged to the this cage is wide, so probably 3.5 meters. And still 3 or 4 times bigger than any of the semi-gums I saw on the dive the other day.
Great white sharks as prey for anything, even orca, is hard to fathom. But the orca may see them that way.
All our evidence points to the fact that the New Zealand orca have a very strong culture of hunting sharks. If the rays were removed from the food web here in New Zealand, chances are the orca would shift their food preferences. And they could start targeting great white sharks in earnest.
So far, the supply of rays and skates has been ample. But add warming oceans to natural fluctuations in all animal populations, and it's hard to predict what will happen.
Looks like it's a skull from a horse. For a shark that size, the liver has to be absolutely huge.
I think we can pretty accurately say it's 4.2 meters long or even a little bit bigger. If that weighs, something like 1,200 kilos, 2,500 pounds, it's a mighty feed for a liver-eating orca.
I think a shark that size could be a feed for a whole family, mate. Not just one orca. This means Kinna or the circles that they're making getting smaller and smaller.
I think you did right, mate.
Behind us? Under the boat. Here he comes again, eh?
The half-dozen white sharks swimming by are more than impressive. To an orca, they may represent the food value of 1,000 rays.
There's another huge one. Here we go. And that other one that we saw earlier was 4.2 meters. I would say that he would have to be well over 4.5 meters, probably close to 15 or 16 feet.
At 16 feet, this one great white shark alone is the equivalent of 200 rays to a hungry orca. It might be a motive for predation.
See the size of a ray liver, which is only just a few pounds, couple of kilos at most, to the size of the liver of these guys. It's no wonder the orca would want to target them.
It's hard not to think an animal as intelligent as the orca, that they're coming through here at the perfect time of year when the livers are fat. They've got to see this as a food source. And even though it's high risk, we've seen in South Africa that they can decide it's worth it. There's such a food source there.
Oh, absolutely.
You've got to wonder whether they're not already onto this. It may have been going on for a long time in New Zealand and we've just never heard about it.
Yeah, exactly.
Ingrid and Kinna have found many similarities between New Zealand and South Africa. In both places, the orca already have a taste for seven-gill sharks. But after the orca killed 5 great whites in South Africa, all the other white sharks disappeared. In New Zealand, all of these sharks are still here and hunting. Then, like a bolt from the blue, Kenna and Ingrid finally see what they've been looking for.
Wow. They didn't look like shark bites.
That really is phenomenal.
Kenna and Ingrid are observing local white shark behavior when a male with a wound catches their eye.
Wow. One with those big wide break marks on his dorsal.
They didn't look like shark bites. To have a look and see if it's orca bite marks.
All right, that's interesting. I'll try to get some close shots of them. We can have a look later on, see if we can figure out what they are.
Jump on your left right there, come on. The one with the right gut. This is the guy we want. We just want him to come in a bit closer, eh?
An unusual mark on a white shark's dorsal fin looks like a bite.
He's just swum towards the bow. He's coming down the port side of the boat at the moment. Coming in close now. Wow, those race marks look really distinctive.
What were those rake marks on the fin? That was fascinating. They were
Yeah.
quite wide apart and very straight, which
Yes.
was interesting. And those were uniform. That was something new to me.
Yeah, and it looks very similar to what I see in the stingrays when the orca have been biting them. You know, you get these, it's sort of like someone's raked the garden, but it's teeth rake marks. And that's what it looked like to me. Yeah, so let me show you these. This is a picture of a orca's teeth. See how the teeth curve backwards? And so here, this is a close-up of these teeth marks, and this is what I think we saw on that great white shark.
Yeah, amazing.
And when you look at the scale on here,
Same thing that with what we
matched with
saw
what
on
we
that
saw.
shark.
Yeah. So if I had to put money on it, I'd say that was orca.
Well, I certainly can't think of anything else, and that is pretty phenomenal. This could well be the evidence we're looking for.
The bite marks could be a breakthrough, the first visible sign of orca on white shark predation they've seen. Ingrid and Kenna devise an experiment that will use sound instead of sight.
Orca use a range of different sounds. They use clicks for echolocation. They use whistles and pulsed calls when they're communicating. It's really impressive.
So they'll use recorded whale sounds and observe how the sharks react.
It's a little known fact about great white sharks that they actually have amazing hearing. So I think if the great white sharks react to orca sounds, that might mean that they've met them before. How they react could possibly even tell us whether that experience was hunting or otherwise. So this experiment is going to be very interesting.
They mount an underwater speaker on the dive cage. The plan: play sounds from several other kinds of whales first
There you go.
to try and draw the sharks in.
Oh, that's perfect.
Once white sharks are around the cage, Ingrid will play the sounds of New Zealand orcas hunting.
Done. It will be interesting to see if they are actually scared of orca, if they know what it's like to be scared of something.
Do you copy me, Kenna?
I Roger, Ingrid, loud and clear. Well, I guess we're good to go.
Well, look, I'm going to start playing the first set of sounds now. This is the humpback whale calls that you recorded.
Roger, go right ahead.
This is humpback whale song. And possibly a great white dinner bell. White sharks are known to hunt whale calves in the tropical Pacific.
Well, that's certainly got a couple of people interested.
The circling great whites begin to rush the speaker and the cage.
The sharks are just all over the cage and all over the sides of the speakers. I can't not to think that they're reacting to that sound, to be honest. We've just got that shark with the two big red marks on its dorsal fin back again. Look at that.
The sharks are clearly responding to the humpback whale sounds. The question is, how will they react to the sound of New Zealand killer whales? Ingrid Visser and Kineskale want to see how great whites react to the sounds of hunting orca. First, as a test, they play humpback whale song. The sharks come straight to the sound. Including the shark with the bite marks on its dorsal fin. They have to wait a few minutes for the sharks to settle down after the humpback reaction.
Now I'm just going to play you the sounds from the orca that eat the salmon. I recorded these guys off North America. Stand by. Can you hear that?
Loud and clear. Ingrid, that's very interesting. To be honest, I can't see much difference in the shark behavior here at all, either. Not much has changed down here.
Yeah, well, I guess that doesn't really surprise me given that these are the fish-eating orca.
The sharks appear unresponsive to the North American orca calls. But these sounds have never been heard before in New Zealand.
Yeah, Kenneth, so now I'm going to play you the New Zealand orca. These are probably the ones that the great whites have heard before. Stand by.
The shark's response was clearly to move away from the sound.
great black shark, that's what it's called. The sharks are there, but they just don't seem to be interested in coming anywhere near us.
Ingrid and Kinna observe that the sharks keep the source of the orca sounds in sight, but stay well out of the way.
It is hard to know what's going on, but, yeah, interesting.
How was that, mate?
Yeah, well, another awesome dive down here, but interesting. We've only really had a glimpse, eh?
The orca sounds change the behavior of the white sharks from fearlessly coming into the sounds of the humpbacks to moving off and keeping their distance when they heard hunting orca. But was this a typical animal reaction to danger?
You know, when you think about the bite marks that we saw that could have been the orca, and you saw the way that the great white sharks, you know, there was a bit of reaction there, but not full on.
Obviously, we'd have to do this a lot of times to be able to say for sure, but maybe actually the sharks aren't so scared of orca.
Well, maybe New Zealand sharks are more exposed to it, like even from when they're little sharks, and so they just become habituated to it.
When orca killed 5 white sharks in South Africa in 2017, many scientists believed it was a first for the region. But is it possible that white sharks have been fending off orca attacks for thousands of years? And what we see are only the most recent incidents in an ancient and ongoing battle.
I guess the big thing for me is, you know, how far are these orca going? And we've got some evidence that suggests that they're at least trying to have a nibble on them. But, you know, I'm curious to know just how far they're taking that.
So far, there have been no reported serial shark attacks in New Zealand. But here, on the far side of the world, the unseen struggle between orca and white shark goes on. In secret, for now.
In Egypt, the land of the pyramids, investigators unearth clues to a story far more ancient than the legends of mummies and pharaohs. They reveal a 40-million-year-old ocean monster, Basilosaurus.
Basilosaurus was the largest animal in the ancient seas. The kind of animal that you wouldn't like to swim next to.
This 5.5-ton prehistoric whale terrorized the oceans for millions of years. Where did it come from? And how is it related to its modern counterparts?
Building family trees, tracing the ancestry and the evolution of whales allows us to tell this story of how whales transformed.
Now, new discoveries from this desert plain are unlocking these mysteries. Investigators uncover lost species and the remains of half-eaten prey that reveal the origins of this great hunter.
It's a really, really big animal with really big, powerful teeth. Kind of reminds me of Jaws, only worse.
To decode the secrets of Basilosaurus, we will see this lost beast like never before, flying inside skin and bone. We'll resurrect its vanished world and reveal how Basilosaurus came to rule the oceans. First light in Egypt's western desert. Investigators are on their way to a mysterious dig site known as Wadi al-Hitan. Egyptian paleontologist Dr. Hesham Salam leads the research here.
Wadi Hitan is a very special place. It's a really amazing site.
For hundreds of years, archaeologists have been uncovering the extraordinary treasures left behind by Egypt's ancient civilizations. But this unworldly place has an even richer past, one that goes back not thousands, but millions of years.
This is one of the richest fossil area in the world. So basically all of these layers contain fossils. This is a lot of fun, a lot of excitement, a lot of fossils, a lot of prehistoric life.
Hesham has just established Egypt's very first school of paleontology. Along with a new generation of Egyptian researchers, he's starting to build a picture of the country's prehistoric past.
We have been unearthing amazing stuff from here. One of the most important discoveries so far for my team was a plant-eater dinosaur that lived here in Egypt 70 million years ago.
Beneath Egypt's shifting sands, Hesham and his team are discovering evidence of a time when dinosaurs once dominated this land. But at Wadi al-Hitan, in deposits formed 26 million years after the dinosaurs went extinct, lie the remains of a truly mysterious beast.
This was a really huge animal, lived here in Wadi Hitan long time ago, which is kind of like 18 meters long, is starting from the tip of the nose till the tip of the tail.
Investigators first discovered the remains of this enormous animal in 1832. It was unlike anything they'd ever seen.
At the beginning, they thought that's kind of like a weird lizard. This is why they gave it Saurus, the Greek name for lizard.
The discoverers named the beast Basilosaurus, meaning king lizard. To find out if this really was a lizard, Hesham takes a closer look at the teeth.
You can see right here, amazing, beautiful set of really ferocious teeth. And you can see a really beautiful serration, which is perfect for cutting through the flesh.
The crucial clue is in the roots of these fearsome teeth. Most reptiles, like lizards, have only one root per tooth, but this beast has two.
This is double-rooted. This is one root, another root, and this is one single tooth right here. They're really different. Definitely Basilosaurus wasn't a reptile because it has actually double-rooted teeth.
So what kind of animal is this? Hesham looks for clues in Basilosaurus's vertebra. At first glance, they are unlike those of any other creature.
What makes Basilosaurus special, that he has really long vertebrae comparing to the width. This is unique for the Basilosaurus.
Lifting up Basilosaurus's bones from the desert reveals an animal that resembles a mythical beast. 67 gigantic vertebrae form a monstrous snake-like body longer than a train carriage. But the arches on the vertebrae are nothing like those of a serpent. They look more like those of a mammal, one that lived in water. Basilosaurus was really a prehistoric whale, the largest marine animal of its day. So why were its bones buried in the middle of a desert, more than 100 miles from the nearest sea? Hesham thinks clues to Basilosaurus's past could lie in the area's unusual rock formations. Wadi al-Hitan is dominated by spectacular sandstone cliffs, known as escarpments, which are constantly eroded by the wind.
Well, if you look at these layers on top of each other, it's like a chapter in a book that telling you the history, part of the history of life.
One geological feature stands out from the others.
You can see all of these boulders with strange branches.
There are hundreds of these bizarre outcrops across the landscape, and they reveal that this desert was once a very different place. One not dry and parched, but watery and full of life.
These strange-looking tubes, some people said it's actually mangrove roots, or other people said They might be like a crustacean burrowing, but either way, they have very clear evidence this area was underwater back then in the Basilosaurus time.
Hesham thinks this area was more than just a mangrove swamp.
If you grab a handful of sand from Wadi Hitan floor, you will see shells, bivalves, and even if you look closer, you might see shark teeth. There's a shark tooth right there. You can see it's really beautiful one. That also indicates that here was a big ocean 40 million years ago.
Today, Wadi al-Hitan lies just south of Cairo, more than 100 miles away from the Mediterranean Sea. 40 million years ago, most of Egypt was covered by an ancient ocean called the Tethys Sea. Wadi al-Hitan was beneath the waters of a sheltered coastal bay, the perfect environment for Basilosaurus to thrive. Scientists discovered the first bones at Wadi al-Hitan in 1902. Many more Basilosaurus skeletons have emerged from the desert sands here ever since. Hesham is still finding them today.
Yeah, look at this white-ish thing. This might be something very interesting to see. This is how we actually locate fossils in Wadi Hitan. And if you give it a close look here, this is definitely something. I can see here like 3 different vertebrae of the Basilosaurus, given the size and the elongated shape of the vertebrae. And also, if you look closely, you can see some of the ribs sticking out. And look at this. I think this is the snout, the very tip of the skull. So basically, we have a skeleton here. This is the skull, and the rest of it is actually hidden underneath the sediments.
This newly uncovered skeleton is one of many scattered across the desert. When the wind erodes the sandstone around these skeletons, the remaining fragments are left sitting on the desert floor. What look like broken rocks are actually 40-million-year-old whale fossils.
You can see all of these piles of stones over there. Just one here, and one there, and one over there, maybe one here, over there. They all are the Basilosaurus skeletons, or ancient whale skeletons, fossils. Because there are so many skeletons in that area, they call it Wadi Hitan, which means the Valley of the Whale. It's a very unique place.
Wadi al-Hitan stretches for 200 square kilometers. So far, excavators have discovered the remains of more than 500 Basilosaurus skeletons here. Hesham believes many more are hidden deep within the area's sandstone cliffs. Each of these lines represents a layer of sediment on the bed of the prehistoric sea. The oldest material lies at the bottom and contains many bones. It dates back almost 40 million years.
Most of the Basilosaurus skeletons coming from the sandy layer that you can see it here.
Hesham thinks there is also evidence of the beast higher up, in a much younger and less explored layer.
Look at this over there. It seems like a nice Basilosaurus vertebra sticking out from the cliff. This is amazing.
This pristine Basilosaurus vertebra is suspended around 20 meters above the ground.
Given the vertebra of Basilosaurus up there and the skeleton that we just saw in different levels stratigraphically, definitely Basilosaurus was here for millions of years. We just found the tip of the iceberg. There's thousands of skeletons hiding inside this sediment.
Wadi al-Hitan is the biggest ancient whale graveyard on Earth. It attracts scientists from across the world to study its remarkable fossils. One discovery from the site is transforming our understanding of prehistoric whales.
What we're looking at is the Basilosaurus arm. It's typically like human arm, composed of the shoulder blades and the humerus, and this is the radius, and the 5 fingers like us.
Experts think Basilosaurus used its front limbs to help it swim, just as modern whales do. But at its rear, it was a very different beast.
For many years, the scientists thought that Basilosaurus had only 2 front limbs. All of a sudden, they found the Basilosaurus had legs. That was a big deal in science.
Unlike any modern whale, Basilosaurus had external hind limbs. The discovery sends shockwaves through the scientific world. Why did this ancient whale have legs? In his lab at Mansoura University, Hesham has a treasure trove of Basilosaurus fossils, but very few of its hind limbs have ever been found.
The Basilosaurus hind limb are really rare in the fossil history. This is because after Basilosaurus died, the current maybe moved the hind limb away from the body.
Basilosaurus has 2 front limbs sitting just behind the head. Featuring 5 fingers, they form the core of the pectoral fins, which the animal would have used to steer its body through the water. But towards the back of the skeleton, sitting right next to the spine, is a pair of hind limbs. They feature a hinge joint, complete with a protective cap. It looks like these limbs could bend, and possibly function like legs. So is Basilosaurus a walking whale? Hesham works with precise casts of the original fragile bones. He pieces them back together to build up a picture of how they were once used.
So we have the hind limbs of the Basilosaurus. You can see this femur. It's not well developed. And this is the tibia and fibula and the ankle bone.
Hesham compares Basilosaurus's legs with those of perhaps the most successful walking animal of all.
This is typically the limb of us, of a human being. And if you compare it with the Basilosaurus femur, the thigh bone, you will see it has the same anatomical features. But look at the size of the femur.
The human thigh bone is around 45 centimeters long. The thigh bone of the giant Basilosaurus is only 25 centimeters.
Really surprising to find a really huge animal like Basilosaurus having really tiny limbs.
With such small legs, Basilosaurus can't have been an expert walker. But some modern marine animals, like sea lions, use small, simple hind limbs to carry themselves more crudely across the land. Could Basilosaurus waddle in the same way? The legs of Basilosaurus could bend and extend like humans, which is the first step towards walking. But to lift a body this large off the ground, the pelvis must be directly attached to the massive spinal column. Hesham and his team plan to 3D scan a Basilosaurus pelvis to see if this is the case. They use a technique called photogrammetry.
This kind of imaging will allow us to actually look in more detail and orient them in different directions, so it would be easy for us to see the different anatomical features.
If Basilosaurus could walk, there should be a socket linking the pelvis to the spinal column, but the scan doesn't show any sign of one.
You cannot see any place for the attachment between the vertebral column and the pelvis right here. So it's totally not attached. This legs is not for walking.
Scans confirmed that Basilosaurus's legs were too weak for walking. They wouldn't have helped it swim either. They were far too small to propel a giant like this through the water. Hession believes there is only one explanation for these mysterious limbs. They are an evolutionary hangover.
The hind limbs actually play a crucial role in the whale evolution. And there is actually a remnant from the hind limb of the ancient whale.
Basilosaurus may never have walked, but it had ancestors who did. Who were they? Where did this prehistoric whale come from? Basilosaurus' skeleton alone can't reveal the identity of its early ancestors. So comparative anatomist Joy Reidenberg from the Icahn School of Medicine at Mount Sinai investigates modern whales for clues.
It's always really hard to understand what an ancient animal, a fossil, extinct animal may have looked like or behaved like, because obviously we can't watch it. But the next best thing we can do is watch its modern relatives.
Joy is a specialist in whale anatomy. She thinks the way Basilosaurus moved could hold the key to its evolutionary origins.
I've always loved whales, and I think part of what really drew me into whales is how beautiful they are, how graceful they are. They swim through the water with such ease. They're so streamlined.
Joy wants to know if Basilosaurus swam like its modern counterparts. So today she is heading out to sea to observe whales in their natural habitat off the coast of New York.
Gorgeous, gorgeous day to be out in the water. There's a bait ball at 11 o'clock, right between the two channel markers. There's a really good chance of a whale coming up right there in that bait ball. Wow, this is so cool. Whoa, there's a whale spout over there, right there at 4 o'clock.
Joy spots a humpback whale, one of the largest species alive today. She wants to know how its tail compares with Basilosaurus's.
There we go. Get ready for tail, 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 tail. Oh, it was so awesome to see that. That tail was up in the air, and you could identify the whale by that tail. That makes me so happy.
The design of the humpback's tail is key to how modern whales swim.
Whales have tails that are called flukes, and these flukes power an up and down motion, and that's what pushes them forward. This is very different than what you see in fish, where the tail is going from side to side.
To find out if Basilosaurus swam with the same up and down tail motion, scientists looked for signs that it had horizontal tail flukes, like modern whales. But the evidence is difficult to find.
The soft tissues of the tail don't fossilize. And even in modern whales, there's no bones in the tail flukes themselves. At first, this was a bit of a mystery to us.
A clue is in the spine of Basilosaurus. Along most of its 18-meter length, the vertebrae have flanges sticking out to the side. But the short, flat vertebrae in the tail section have no flanges. Modern whales share this feature. It's where their flukes attach to their bodies. Basilosaurus only had room for a small fluke on its tail. So to propel its 7-ton weight through the water, it would have to move its entire body up and down through the waves. Basilosaurus may not have been as sleek and graceful as a modern whale, but the way it swam reveals that both animals share a common ancestor. Joy examines vertebrae from 3 modern whale species, the humpback, the porpoise, and the dolphin, to discover more about their mysterious relative and how it moved. This spine hides a remarkable feature that originates from the early ancestors of all whales.
What we notice is these spinous processes that are going up this way dorsally are flanked on either side by these projections The projections are making this type of an interlock. That allows sliding in the up and down direction, but very little movement from side to side. So we can move these vertebrae back and forth this way, but it's very hard to move them, to twist them side to side.
These interlocking vertebrae are crucial for stabilizing the whale's spine as it swims. By preventing side-to-side movement, they allow the spine to flex up and down with maximum efficiency.
So you see them in the porpoise, you see them in the dolphin, you see them in the humpback whale. All whales have this. If we could find another animal with similar restrictions on the spinal movements, it would give us another clue as to where the ancestors of whales came from.
Joy thinks these ancestors were completely different to the whales we know today. 400 million years ago, most life was still in the ocean, where it had first developed, and fish swam with a side-to-side motion. Over time, some species left the water and learned to live and walk on land. When they developed into mammals, their spines evolved to move up and down as they ran. Then, about 50 million years ago, a group of deer-like mammals returned to the water. Their hind legs disappeared, and their tails developed flukes for propulsion. But to this day, a whale's spine still moves as if it's galloping, just as their ancestors once did on land.
So why did the whale's ancestors decide to go back into the water? After all the evolutionary effort that went into becoming a land animal and adapting to galloping on the land, why throw that all away and go back to the water? It's a bit of a mystery.
Discoveries from Wadi al-Hitan are helping scientists to work out how Basilosaurus fits into this strange story. Tiny legs found alongside the enormous skeletons are clues that this ocean giant had land-dwelling ancestors. Paleontologist Steve Brusatte from Edinburgh University is an expert on the evolution of mammals.
Building family trees, tracing the ancestry and the evolution of whales allows us to tell this story of how whales transformed.
Steve thinks there's a clue to the origin of Basilosaurus, hidden inside its skull. It resembles that of a crocodile, but double the size. Its nostrils have fused and moved up the head, closer to where modern whales have their blowholes. Its brain probably weighed only 2.5 kilograms, which means it was smaller than the brains of today's whales. And tucked away under the skull, it had a bony shell called the bulla, which contained the inner ear. It bears a striking resemblance to the bulla of a prehistoric land animal found on the other side of the Tethys Sea in Pakistan, called Pakicetus.
Now, Pakicetus, it looked kind of like a wolf. It's an extinct mammal. It's known only from fossils, but it's a very important mammal. And in fact, I think it's one of the most important discoveries in all of paleontology over the last several decades.
Outwardly, Pakicetus was a classic land mammal, with 4 strong legs which allowed it to walk on land. But the shape of its bulla links it with Basilosaurus. Steve thinks it shares this feature with other whales too.
The bulla bones of whales are really distinctive. Their bullas are really thick and really robust and really dense, and especially the rims here. And that helps them hear better underwater. Now, what's really intriguing is that we see these thicker bullas with these thick rims in Pakicetus.
Pakicetus's remains predate Basilosaurus by nearly 10 million years. While they were still only around 1.5 meters long, they had begun to develop the distinctive underwater hearing apparatus of a true whale. But did Pakicetus ever go into the water? Steve thinks the answer may lie with a well-known living species.
Hippos are the closest living relatives today of the whales. They probably last shared a common ancestor 55-ish million years ago. And there's some commonalities between the way hippos live today and the way that we think some of the ancestors of whales lived tens of millions of years ago.
Hippos spend up to 16 hours a day submerged in water. Their skulls are specially adapted to help them see above the waterline.
Here is Pakicetus' skull from above, and you can see here are the eyes, and those eyes, they would have been on the top of the skull a little bit so they could peek out. So if this animal was in the water, the eyes could see above the water a little bit, kind of like a crocodile and kind of like this hippo here. And so this was an animal that was at home on land, at home in the water.
Pakicetus fossils are a window into the time when Basilosaurus's ancestors were taking their first steps in the water.
Where you really see its behavior is when you zoom in on the teeth, and here's some of the teeth of Pakicetus. And these teeth are sharp, and they are pitted and scratched. They have all kinds of wear on them from eating food, and not just any food, but eating flesh, eating meat, and it was probably fish that they largely ate. And it was from these sort of behaviors that these mammals went into the water.
Pakicetus entered the water to hunt, kickstarting the process of evolution that led to the rise of a predator like Basilosaurus. But Pakicetus never made it to the open ocean. What attracted later whales to move into deep water? On the outskirts of Wadi al-Hitan, investigators discover astonishing remains that could help answer this question. The bones they unearth here are from a completely new species, which they name Phaeomycetus anubis.
This is Phaeomycetus anubis. We have nearly complete skull. We're just missing a few pieces of the front and the cheekbone. And it's kind of like the shape of a very ancient whale like Pakicetus from Pakistan.
Hashem can figure out how Phaeomycetus anubis fits into the timeline of whale evolution from the age of the deposits it was found in.
Although the Phaeomycetus were found very close to Basilosaurus, it's actually coming from different layer, older layers than Basilosaurus. So it would fit in the middle between Pakicetus and Basilosaurus.
Phaeomycetus anubis could be a missing link in the whale family tree. 50 million years ago, all whales lived inland, in freshwater streams around India and Pakistan. 2 million years later, they first moved into the area's coastal waters. By 43 million years ago, they had crossed the deep ocean, so we now find their remains in Africa and North America. Today, whales have conquered the planet and can be found in all the world's oceans. Why did species like Anubis give up trickling streams for almighty oceans? A clue lies with its fearsome skull.
So all of these gap or hole will fill with the chewing muscles to go through the skull and also attach it to the lower jaw, which make it really deadly bite indeed. We can say Phaeomycetus anubis were preying on turtles and sea cows and large fishes, maybe also other whales.
The early seafaring whales, like Anubis, evolved to eat far larger prey than their freshwater ancestors did. By entering the oceans, they unlocked the world's biggest pantry, paving the way for the likes of Basilosaurus. How did Basilosaurus rise to become the apex predator of the oceans? Among the incredible hoard of fossils found at Wadi al-Hitan is evidence for how Basilosaurus hunted. When paleontologists dug up a Basilosaurus skeleton, they found strange objects that didn't belong to it. Scattered around the area of the stomach were fragments of other animals. possibly part of this whale's last meal. Among them, a 5-meter-long shark, and one of Basilosaurus's close cousins, Dorodon. Both of these animals were apex predators themselves, but they were no match for Basilosaurus, which sat firmly at the top of the food chain some 40 million years ago. How did Dorodon end up as Basilosaurus's dinner? A typical Dorodon is 5 meters long, with a skull about 2/3 the size of Basilosaurus's. But when Hesham looks closely at the teeth, it's clear that this is not a fully grown Dorodon.
Well, like any other mammals, they are actually replacing the teeth over time. You can definitely see the adult tooth as actually replacing the baby tooth right here. So this is the baby Dorodon still growing and replacing their teeth.
This juvenile Dorodon is part of a strange trend seen across the site.
Here in Wadi Hitan, we find half of the Dorodon specimen are babies. But unfortunately, we didn't find any of the Basilosaurus baby here.
Why are there so many Dorodon young here, and yet no Basilosaurus young? Hesham believes it's a relic of Basilosaurus's brutal hunting strategy.
Based on what we see here in Wadi Hitan, definitely the Dorodon come here just to give birth, and Basilosaurus come to hunt the Dorodon and its baby.
The sheltered bay of Wadi al-Hitan was the perfect place for Dorodon to deliver its offspring. But it was also prime hunting ground for a hungry Basilosaurus who came to feast on the defenseless juveniles. To find out how it tackled its prey, Joy Reidenberg compares Basilosaurus' teeth with those of its modern counterparts.
What we have in front of us here are a whole bunch of teeth from different types of small and large whales. Each of these different types of teeth had different functions. And if you look at the teeth, we get an idea of how they're feeding.
First, she must select the species of modern whale that is the closest comparison.
To the untrained eye, Basilosaurus probably looks a lot like modern-day really big giant whales, such as fin whales, blue whales, humpback whales. But in fact, those whales are very different because what they feed on are very tiny little animals. They don't hunt with teeth in their mouth. They use baleen plates. This, for example, is a baleen plate from a fin whale. And it uses these little hairy brush surfaces to trap prey. Very different from what Basilosaurus was doing.
With the modern giants out of the running, Joy turns towards today's smaller whale species.
If we want to compare Basilosaurus to a modern whale, it would have to be the toothed whales. But if you look at most of the modern toothed whales, they're relatively small, like dolphins. It's not really a very good comparison to Basilosaurus because they're eating very small fish.
Most toothed whales hunt on much smaller prey than Basilosaurus did, but one species is a clear match.
The closest to a Basilosaurus would probably be the killer whale, which is one of the few species of whales that hunt other whales.
The orca, or killer whale, is the apex predator of the modern oceans, capable of killing whales twice its size. Its teeth are its secret weapon.
We're looking at a replica of an orca or killer whale skull. If we look at the shape of orca's teeth, we get an idea of how they're feeding. What they're doing is using these sharp cone-shaped teeth to puncture into the flesh of the whale that they're trying to kill, and they can tear away pieces of that flesh. This is good for grabbing prey and swallowing it whole, like big salmon, for example, or taking a chunk out of a larger animal, like another whale, and then they swallow that chunk whole.
To find out if Basilosaurus did the same, Joy compares its teeth with the orcas.
This is a skull of Basilosaurus, and what we notice is it has 4 different types of teeth in its mouth. That's very different from modern whales, which all have the same kind of teeth. If we look at the shape of the back teeth, we notice that they're very different. They have multiple cusps and they overlap each other, which means that they may have used them for processing their food.
Unlike the orca, Basilosaurus had back teeth that could slice meat into small, easily swallowed pieces. But their front teeth have more in common.
This is an orca tooth, and look at how it's a similar shape. It's cone shaped with a little bit of curve. This is a tooth for biting and puncturing into prey. Basilosaurus could use its front teeth in the same way that killer whales do use their front teeth to pierce into their prey and bite chunks off.
Basilosaurus could have used its front teeth to tear chunks from its living prey. Further evidence of their hunting techniques comes from a remarkable find. A haul of juvenile Dorodon skulls, dotted with bite marks so deep they would have been deadly. When researchers compared these marks to Basilosaurus teeth, they were a perfect match. It looks like Basilosaurus attacked from the side and chomped down hard to disable the Dorodon before feasting on its flesh. Basilosaurus's ferocious hunting tactics took it to the top of the ocean food chain. But if it was such a skilled hunter, why is there no Basilosaurus swimming around today? Hashem thinks a sudden change in Egypt's landscape could help explain why Basilosaurus disappeared at the end of the Eocene epoch.
At Wadi Hitan, you find the Eocene layers, which is like marine fossils everywhere, whales, sea cows, and turtles, and so on. And all of a sudden, that's changed at one single layer, and all whale fossils disappear from the area exactly at 34 million years ago.
After this time, very different species seem to have inhabited the areas around Wadi al-Hitan. Creatures that lived not in the sea, but on land.
Not far from Wadi Hitan, all of a sudden you find terrestrial mammals, fossils everywhere, starting from different type of ancient elephant. This is one tooth of Meryutherium, the very primitive elephant without any trunk. And sometimes you find bats. This is the lower jaw of a bat.
Hashem thinks one extraordinary discovery is most revealing of all.
One of the most important fossils ever found from Fayoum would be this Egyptopithecus, the Egyptian monkey. This is the cast of it. This is the face. You can see the eyes and the nose, and if you flip it, you can see the teeth. This is very important fossils in the history of human evolution.
Egyptopithecus was less than a meter long, similar to a modern howler monkey. Some scientists believe that it was an ancestor of modern humans. Far from a marine species, this primate lived in a woodland habitat.
Egypt changed from the bottom of the ocean to really green forest, full of really amazing fossils.
What triggered this abrupt change in the landscape? 34 million years ago, Earth begins to cool. As water freezes into ice, sea levels drop. The Tethys Sea retreats from modern Egypt, and Wadi al-Hitan is no longer underwater. Experts believe the sudden shift in climate contributed to Basilosaurus's extinction. In this new world, different whale species emerge.
After the Basilosaurus time, the whale divided in two main groups. The baleen whale, that has no teeth at all, and also the toothed whale.
Modern toothed whales, like dolphins, have built on Basilosaurus's predatory prowess by evolving a remarkable new ability, echolocation. This allows them to navigate and hunt with their ears by detecting the location of nearby objects from reflected sound waves. Basilosaurus couldn't echolocate, but Hashem thinks the shape of its skull shows how this remarkable superskill developed.
The scientists said that's the asymmetrical skull of Basilosaurus that's actually inherited to the modern toothed whale as well.
Basilosaurus's lopsided skull gave it directional hearing underwater, the first step on the path to echolocation. It would take other species millennia to refine this skill. The sophisticated whales that rule today's oceans owe a huge debt to their prehistoric cousin. Egypt's ocean behemoths may now be a thing of the past.
Basilosaurus, probably one of the most impressive fossils that I can think of because of its sheer size.
But their bones are still revealing one of the most incredible evolutionary tales of all.
Basilosaurus records that moment in whale evolution where whales left the land behind and went all in for living in the water.
Paleontologists continue to dig in search of the next piece of this prehistoric puzzle.
Being here in the desert looking for prehistoric life is just amazing. You live in another world. It's really something not many people do, so I'm really lucky to do that.
It's thanks to ancient species like Basilosaurus, the prehistoric colossus, expert swimmer, and fearsome hunter, that we have the majestic ocean giants that we know today.